So, hello guys, myself Asmit and I am subquad of ML and we will be taking a session on linear regression today. So, I will be discussing the theory part, what is the theory behind all this linear regression and all, the mathematical part of so-called linear regression. So, first of all, giving you just a basic knowledge of statistics, because first of all in linear regression this is a main part of statistics, frankly speaking. Statistics with a huge amount of data being dealt on a computer is machine learning, to be very specific. So now the techniques that are used in these statistical methods are basically the algorithms of machine learning. That's the thing. So in linear regression, one thing that you will be noticing quite often is the variance and the covariance. So the thing is of a data. So for the variance and covariance, this shows how much the data deviates from its mean. Mean of the data means the average, simply. So mean, average and expectation. All three terms are same in the terms of statistics. So basically speaking, if I write E of x, this means average of a random variable x. Now what is the random variable x? Now x is in terms of data that you are given in machine learning, these are the features that you are given. Speaking frankly, the features that will be given along with the outcomes are these variable x. That is, what are the plot points that you have. So in case of linear regression, if you have a data points, like in a two-dimensional case, if you have this kind of data, all these data points are those x, and the distribution is linearly distributed over the space. So linearly distributed because it follows a straight line pattern. That is why it is linear. So I can draw a straight line that goes through all of these points, satisfying them. That is why it is linear. So a non-linear graph, as you can imagine, it will be just that you cannot plot them in a single line, as you can see here. So this is a parabolic curve that it can fit. So it will be a polynomial distribution, because you can predict this with the help of some a of x square plus b. Now this a and b are two constants that we have to figure out mainly. So now how these things work, that is the question. So now what happens is, you have to see the data first. Speaking of the data, like household prediction data or any kind of data that you are given, the thing you have to do first is plot them. For simple cases, you have to first plot. When you are plotting each of the points, like if you have, suppose x1, x2, x3. Now speaking of this x1, x2, x3, these are basically the features that you have. Features like area, number of bedrooms, and maybe luxury. Luxury includes AC, having a AC, air conditioner or not, and all sorts of other things like having a geyser or not. So now the thing is, you have this x1, x2, x3. Now you cannot plot a x1, x2, x3 in a two-dimensional space. You have to have a four-dimensional space to plot all the three things together. That's clear, I guess. Because not only you have x, you have y also. The price. Because you have to predict the price. So to predict the price, if you have to plot the price, then you also need to plot the y. So you will need a four-dimensional space that you won't have. So what you have to actually do is, you have to plot x1 with y, x2 with y, and all other combinations that you can make with y, and then with x1 and x2, x1 and x3 and all these combinations will give you a rough idea which algorithm or what process you should take. Would you be taking a linear regression or a polynomial regression? Suppose for example, the area, the price, the number of bed and the price, these two and this one follows a linear pattern. Means x1 with y is a linear pattern, x2 and y is a linear pattern, but x3 and y are not linear. So what will be the best case scenario for me is to take a linear regression pattern for first trying out the algorithm to see how it's working, and then go for x squared. X squared means you have to take ax squared plus bx plus c. So now you will be thinking, like, I have two features, x1 and x2. So how am I going to write this x, right? So what you have to do is a1 x1 square plus a2 x2 square plus a3 x1 plus a4 x2 plus a5 x1 x2 plus a6. Fine. You have all the combinations of x1 x2 and this equation that I am supposing is known as hypothesis. H of here AI. I am writing AI because all these 1, 2, 3, 4, 5, these are the constants that are not being till selected right now. I have put random numbers in the place of A1, A2, A3, A4, A5 and A6. Fine. So after what I will do is I have to fit this function. Now what is fitting of a function? Fitting of a function means tuning A1 and A1 till A6 to such a value such that you have the curve that satisfies this value accurately. More specifically, it shouldn't be accurate to such a point that it overfits. Now there is a concept of overfitting and underfitting. Overfitting means you are predicting 100% correctly in your training data. Now the problem, when you have a testing data, you won't be having that testing data in your training set. So if your data performs if your model performs 100% on your training data, it won't be that a good predictor for your testing data. Why? So you will see when we run the code. We will be having a coding session after this. So he will explain like how actually overfitting works and underfitting works. Underfitting means this is the data and like I did a regression of this, linear regression. Now this is the underfitting. This causes underfitting because this will not be predicting what it should have been. This is underfitting, and what is overfitting is like this one. This may be overfitted model. It covers all the points perfectly, but the thing is it won't be predicting perfectly for the new data points to come. Now after this, for linear regression, actually the term linear means why actually we are discussing about linear regression is because after we go on to other things like logistic regression, neural networks and all the other topics that we are having, the base line that we have is always a linear regression behind the model. Because this hypothesis function that we are taking, this is always taken to be a linear polynomial or the concept behind linear regression that works on the basic principle of this. So now moving forward is like this one. So now what I am telling is like you have pair of points x1, y1, x2, y2 and all. So this is actually the data point, like let me take a made up data of maybe y equals to 2x plus 0. I can take a linear function y equals to 2x plus 0. So what are the points x and y? 1, 2, 2, 4, 3, 6, 4, 8. So this data given to you in the form of tuples. Tuples means 1, 2, 2, 4, 3, 6 and 4, 8. The data is given in the form of this way. So what you have to do in the coding part, you will be learning how to get this data and all. But the thing is, what we have to do in regression, you have two problems. Either you have to regress the problem or you have to classify the problem. Regression means you have to predict a data that is having a continuous range of value. Continuous range of value means money. Money can have a continuous range of value. By telling money can have a continuous range of value, we will be predicting like 1444.3619. You will be obviously telling this 3619 is not possible in paying, but obviously you can round it off to 3 and 4, 3 and 7. You can round it off, or maybe you can just delete whole part and give it a round up. You can round up the figure to the next whole number. That you can do. So that is why we consider price like things to be a linear case. And linear regression is mostly used when you have an infinite range space. Infinite range space means this x is your domain space and y is your range space. Now when your range space is actually infinite, then you have to take a regression case, because in an infinite case you cannot have infinite classification classes. In classification you have to do classes, like how many types of data you have. Like I have a bottle and this is a remote. So I am classifying, now the model is classified either it is a bottle or it is a remote. There are not infinite cases that I have to deal with. So that is why I will be using a classifying case rather than a regression case to get the accurate predictions. In classification case, that is what I have told, that there are k classes 0 to k minus 1. Actually in computer science, our basic motto of indexing is from 0. It is 0 indexed values, not 1 index. 1 index means the array starts from 1 and 0 index means the array starts from 0. So in machine learning also we prefer to use the 0 indexed case, because in CS everywhere it is being a common general form of using 0 index value. So it goes from 0 to k minus 1, and a specific case of classification is the binary classification. Now binary classification is done in the form of logistic regression. Now you will be thinking, now why I am telling logistic regression, why not logistic classification? So let me clear it up. So logistic regression, the logistic function. Anybody knows what is logistic function? Logistic function. You are close enough, just a bit off the point. It gives a value between 0 and 1, not 0 or 1. It gives a value between 0 or 1. You fix a threshold when it will give a 0 or when it will give a 1. That is thresholding part. Thresholding means I have a value 0.59, you will consider it as a 1. You have a value 0.33, you consider it to be a 0. That is basically rounding off. So basically that is why in logistic regression the values will be from 0 to 1, but the values are continuous and you have an infinite range space. That is the actual definition. Fine, because the range space is infinite. From 0 to 1 there are infinite numbers, infinite real numbers to be specific. Okay, so moving forward. So now this is the thing, let me turn this one. On हुआ है क्या? नहीं हुआ. नहीं हुआ तो ठीक है छोड़ो. So the thing is, first thing we have to do is collecting the training data. So always you have to collect the training data. After collecting training data, you cannot directly use it in your model, right? You have to clean the data. The so-called cleaning means you have to remove the outliers, you have to remove the redundant factors in the data, you have to remove the useless items in the data. Useless items, being specific, useless is like you have 1 comma 2, the previous example y equals to 2. Now you have 1 comma null, or maybe nan. Sometimes due to computer errors or miscalculations, these kind of things happen, like you have 1 comma 2, fine, but you have 1 comma nan also. So you have to remove this data from your data set, because a model cannot predict a nan value. Nan means not a number. Not a number is a big problem for the data set, because it will increase the redundancy, because 1 is already there, and even after 1 there is this error. Whenever you are going to plot, you will get an error in this case. So you have to remove these all nan values from your data, such that there does not exist a problem. Now, can you suggest me a thing that you can do without removing the data? What you can do here? Like suppose 2 comma 4, 2 comma 4.1, and maybe 2 comma nan, 3 comma 6, 3 comma 6.1. So can you, this kind of data you have. Now propose me something without removing this data. Means I won't be removing these 2 rows. I do not want to remove these 2 rows because the number of data points that I have is too small. The number of data points is too small to have a big model running over it. So I don't want to remove these points. So what will you do? Can you just suggest me?
Replace it by mean.
Yeah, that is the thing you can do. You can replace it by mean. Just take this, all the things that doesn't have a nan value, take it, take the mean, put it there. One thing you can do. Another thing that you can do is little bit more advanced, is you can take the mean x bar. This is x bar, that is the means default sign. So you can add some function f of x. Now this function f of x is a noise function. Fine. What is a noise function? Noise function is basically a function that gives you a value between I will be setting the range that it will be giving me the output of. Let me suppose I am setting it a range of 0.0 and 0.1. So this gives out a random value between 0 and 0.1 on the basis of the data that x have. This x, it can take x as an input, it may not take x as an input, it can take a random number and directly get a value between 0 and 0.1 and give it u as an output and add it to the mean. And why I am doing this? I am doing this because to overcome the problem of overfitting. Because suppose a case where your mean overlaps with your actual data that is actually there. Maybe your mean is 2 and this is coming 2 and maybe okay, let us suppose your mean be 4 to 6 and 6 12, that is be 1 2 3 4 5 6, let it be 2. So it is kind of 2, the mean is actually kind of 2. So if you just put 2 over there and 2 over here, maybe let us suppose the mean is 2. So if you go on putting 2, it may overfit because your data will be like a polynomial, and then you will put a polynomial curve. When it was a linear, you put a polynomial degree, then it will overfit the data, and this will cause a problem. So rather than that, putting some noise into the data will help you overcome this overfitting or underfitting problem. Underfitting problem can be used by another technique like augmentation of data. So what is augmentation of data? Augmentation of data will be like you have very less number of data and you want to have more number of data. So just suggest me a point that you can have, means suggest me a model that will give you some extra data points based on this data. Can you suggest? Whatever I have just told, in the basis of that, suggest me something.
Double of each double.
How will you know that double is the actual function? Let us suppose it is a non-linear function of e to the power x and x. Suppose. So doubling won't give you the actual thing. Ain't it correct? So doubling is not the answer. Anything else? In linear case where double is actually the m, when m is actually 2, doubling it will work. When m is actually 4, 5, 6, it won't work. So now give me something which should work in non-linear case, in linear case also. Anything? Anyone? Just think about whatever I told till now. The answer lies there only. Nobody? So actually what you will do is, the best thing that you can do is just take the noise function, add it to both of them. The easiest thing you can do. Take the noise function and add it to both of them, that is adding a random number between 0 and 0.1, very small, or 0. Even let us go for 0.00001. So this will just give you more points because you have very less points, so you have a little bit of more points. Anyways, augmentation is more advanced concept that will be dealt later on. Augmentation is not really used in the case of linear regression and all. It is actually used in the case of image classification and all. That's the case where you have very less images. To get more number of images, you do something to get this more number of images. Then we will be discussing about this linear, come back to linear regression. So, okay, in linear regression, after selecting the model is basically whatever I am telling, like model is the thing that I am choosing. This hypothesis that I have written earlier, like h of theta, theta is the basic standard deviation of AIs, the whatever AI I was using, theta is the basic definition, so theta 0 plus theta 1 x1 plus dot dot dot. All those terms will be known as the hypothesis, and this function makes up a model. In machine learning, you will be calling it as a model rather than a hypothesis function. Hypothesis function is basically the more mathematical term of a model. Now, after selecting the model and the loss function, now what is the loss function? You are predicting something on basis of something. Something means theta 0 and all theta is, you are predicting something. So let us suppose you have a value of 1, 2, 2, 4 and 3, 6, and you take y equals to, you suppose you have taken h of theta is equal to, suppose 0x plus 0. You might take random numbers. I have told you can take random numbers. So let us suppose the computer have taken this thing and I have told it to linearly regress the problem. So what happens is, for each of the 1, 2 and 3, so each of theta 1, 0, 0, 0, for each one of them it had predicted 0. Now it is predicting wrong. So to make it correct, what I will do, I will introduce a loss function. So the computer should know how much it is going wrong and how much deviating it is from the actual data. So this loss function will calculate the loss. That is why its name is loss function. Loss function, maybe I can define it. So can you just give me a loss function? Just think of a loss function such that model will know that it is going wrong. Can anyone think of it? Think of a loss function such that model will know what is a loss function. Means I have described what is a loss function, that you will know what is loss. So now can you just guess what can be a loss function? Can be. Any guess? Mean average error. Okay. Now error. What are you defining as error? Mean average error, I get it. But the mean average error is not loss function. Mean average error is actually cost function. What is error? So what are you defining that error? The error is actually caused by loss function. What is the error?
Difference of y.
Absolute difference. We take absolute difference. Why? Now let me give you an example. Why we are taking absolute difference and not only difference? Why? Can you give me the answer? Why you are taking a absolute? Why you should take a absolute difference rather than difference? That is the thing. You may have a positive loss and a negative loss. You add up, it goes to 0. So model thinks, oh, it is predicting correct, but it is not. So that is why you take the absolute loss, absolute error. That is why what you will do is y minus y bar. So y bar is basically the predicted value. So this thing is known as MEA, or after this it will become MEA. Now this is AE, absolute error. And after this, what you will do? This is not super efficient in the case where there are not too much outliers. Outliers means, suppose you have a data. Let me suppose you have a data like this. Fine. This is clearly a linear function. Great. Now you have data here and a data here. These are known as outliers. Basically, outliers are those points which are drastically different from all other neighboring points. Fine. So either you have two options. Either remove these 2 points. That is the option when you have huge amount of data and it doesn't cause any damage to your model. You can remove these outliers. Or other thing that you can do is, actually outliers in real life world simply is a basis of exceptions. It is exceptional case. You won't be predicting values for exceptional case. You will take a general case. Like this much, the house might cost this much, but this can be an exceptional house. It can be very low priced. Maybe someone died earlier there. That can be the case. So that is why we do not take care of these outliers. Suppose the outliers are like this. 2-3 outliers are there, which are outliers, but they are not much deviating from the data. But if they are considered to be outliers, then in that case, AE, this absolute error works great. But when you have not too much of these outliers and your data is quite great in the sense, suppose you have a data like this one. In this case, this data is actually considered to be a good data. So great data it has. So now after having your hands on your code and all data, you will come to know by yourself which data is good and which is not. In this case, you will be using MSE, means squared error. Squared error means basically we are squaring this. So actually, moreover that there is another problem with absolute error that you should know, that what problem can actually absolute error cause. Means what we have to do, I will come to that later. Let's go to this. Solve the learning problem. What we have to do, we have to minimize this loss. Obviously, to make the model more accurate, we have to minimize the error it has. That's as simple as that. Minimize the error will give you the accurate predictions of other data, and we will just obtain the predictions on all the test data. So now this test data should be randomized. It should be randomized so that the model does not overfit on its training data. Means the testing data should not be present in the training data. It should be other than that, and it should always be randomizedly distributed. Okay. So and after that we will evaluate the scores. Scores means how much accuracy is there, F1 score is there, recall is there, and all sorts of things. We will do that. So after this, I guess I have defined all of these things. You can just go through, because maybe I have defined all of them. Is there anything I have to discuss on this? I guess I have. Is there anything? Any doubts? Anyone having any doubt? No doubts. So I am moving forward. So this is a data which, okay. So can you give me what is a single outlier point? Can you get where is the outlier? This? Yeah. This is the outlier. So either you can remove that. The best thing to do is remove this outlier from this data. And even here in this case, suppose you take this is a linear case, you are getting it from seeing the data, right? So now let me ask you a question. What will happen if I take a polynomial regression? Polynomial regression means the degree of the variables, means the degree of the polynomial that I am taking for regression is higher than 1. Anything higher than 1 is a polynomial regression. The algorithm will be same as a linear regression, means the algorithm whatever will I do with this, how to minimize the loss, how to calculate the loss, they are the same, just defining the hypothesis is different. So can you tell me what will happen if the degree of this polynomial is 100? If I take a polynomial of degree 100 for regression of this data, what will happen? Means it will be like this, right? It will be like this. So what problem will I face if the prediction goes like this? Overfitting. So you have got my point, that it will cause overfitting. Okay, so now coming to the loss minimization part. So I have discussed with this thing. So now this part is the hypothesis h of theta. Whatever I am defining h of theta, it is not universal. You can define h of ABCD as if they have defined A and B. Now this M denotes the number of training data, means which training data sample I am taking. Because you can see this M is actually this M, it is not the degree. To be very specific, it is not the degree, it is the training samples number, whatever I am using. We will provide you the slides. No need to take pictures, we will provide you the slides. So this is h of theta and this is the actual data that I have. So this is actually the MSE that you are telling, that MSE, MAE and MSE. So now we are taking a MSE over here. Now why MSE? The question arises, right? Why am I using MSE not MAE? So to minimize a function like this, what are you gonna do? You have done MA101 and all. So just give me something like how can I minimize this function? What will you do? You will differentiate it. So now tell me, why aren't we using MAE? E means mean squared, means absolute error, not mean squared, mean absolute error.
Because it is not differentiable at x.
That is the thing. It is not differentiable at 0. Means mod of x is not differentiable at 0, or being specific, MAE is not differentiable everywhere. There is at least one point where it is not differentiable. So now if we cannot differentiate that function somewhere, then we cannot differentiate this function, it will cause a problem. Then we have to, for each of those functions, each of those MAE's number, we have a point that is not differentiable, which will cause a great deal of stress on us. So now that is why actually we take MSE is great, means MSE is great just because of that. So now the thing is, even if we do not differentiate, what we can do? Now the question arises this, because computer cannot differentiate. The big thing is you cannot get a differentiation directly out of this. Means if I give computer x squared, the computer won't be giving me 2x. Whatever you are seeing, if you are using SciPy and all, they give you 2x because they are trained on a data. Like if this follows this and this is following literally kind of this, then they will approximate its value to 2x. That's how their backend works. They do not know like ddx, or they do not know the formula like ddx equals to 2x or ax square equals to 2ax. They do not, the computer doesn't know these kind of things. So can you think of a way when computer cannot directly differentiate, what we can actually do? So in mathematics we can do one thing that is known as normal equation. If computer cannot differentiate, we will directly give it a differentiated final form where it can directly put the values of training data that we have and get directly the answer of thetas, individual values of theta. So now let me rub this and let me turn off the projector. So are you guys all okay with this? Means I am going a math oriented session. This is actually a bit of math oriented session rather than a coding oriented. So are you all guys okay, right? All okay with it? So now let me go with the normal equation. Okay. So how a normal equation is actually defined is like, I have defined h of theta. It is a standard, so I am writing h of theta. No worries. So like theta 0 plus theta 1 x. Simple linear equation of one variable. You have one input variable, one output variable. Done. So now if we write like the loss L, loss will be theta 0 plus theta 1 x minus y whole square, right? Now this is known as the loss function. I will be defining a cost function j. Now cost function is basically the average of all the errors that I have, is the cost function. So what will be the average? Let us suppose you have m training examples. Let us suppose we have m training example. So 1 by m summation over all the m's that we have, theta 0 m plus theta theta 1 m, not theta 0 m, x m minus y m also. So these are not degrees, these are basically the training example. Fine. So this will be the cost function. Now the thing is, can you tell me why I am taking the average, not the sum? Any idea? It means it is basically I am scaling down, but why I am scaling down? Anybody? No, it won't be minimizing the loss. Loss is loss. We are just scaling down the loss. Scaling down. But why?
Increasing accuracy.
Increasing accuracy. How? Least possible error? No, not like least possible error. The thing is, we are scaling down because if the values are too large, because think of a case where the error is like 100, it gets squared, so it gets to like 1000 maybe or 10,000. 10,000. So it gets to 10,000. Now the problem what occurs is like if the error is 10,000, it exponentially increases the cost function. So what actually will happen is your computer will predict wrong sometimes because it has a range of values that it can go into. It has a range up till that it can go small, and it has a range up till that it can go big, and after that it will give you either infinity, INF or NaN, not a number. So that is a problem with the computers, not the problem with the function. There is no problem with the function. We can take it, a human can differentiate it and get the correct answer, but not with the computer. It will get such a huge value, it cannot calculate that. It will throw error. So that is why we are actually scaling down the factors. And in most of the cases you will be seeing in machine learning, we always kind of scale down so that the computation reduces. It reduces the computation power required by the computer. Fine. So that is why actually we are reducing this value, and scaling down the value. So this is the j. So now what we actually we have to do is we have to minimize this j. So what we will find then? We will find mean j. We will minimize this function j. So what does minimizing a function mean? Minimizing a function means we operate something. Means this is everybody is familiar with this operator? I guess you are. This is the delta operator. What it does is basically differentiate. Complicated term for differentiation is this operator, del operator. So what I will do is I will make del j 0. This is what you all have been telling, like differentiate and make it 0. So why actually I am using del? Because it can have multi-dimension. In a multi-dimensional case where you have multiple features, that time you won't be writing del x, del y and all. So rather than that, you will just use a delta j. Delta j equals to 0. So now in solving this, considering this and this to be constant, you will consider by human, means a human will calculate this thing, not the computer. Will differentiate this whole term, get the final value, sum it up. It goes to something like that actually comes over to, actually we can do it in this summation way, but let me give you something else, that how summation can be represented in some other terms. Means let us suppose you have two matrices, you may not have, okay, now you are having linear algebra, right? Now you are having linear, so you don't know actually, maybe you may know also. So what will happen if I say, like, let me take a small one, 1, 2, 3. I can do this, right? So what will happen if I do this? What will happen? It will give me a 2 cross 2 matrix. So we won't be doing this. We need a single number. So what we will be doing this is 1 cross 2. We will be doing this. So now if you think what actually happens if we do this is like 3 gets multiplied with 1, and 4 gets multiplied with 2. Fine. So what will happen if I write theta 0 and theta 1 here and 1 and x over here? What will happen? So it will just give me this function, right? This. You will get this function, right? So if I modify this function to be a matrix of theta and okay, now there are two conventions. Either you will write always in row or either you will write always in columns. So in this case, let me define it as, okay, let me take theta as to be a row vector and x to be a column matrix. X can be a matrix, okay. So now how x can be a matrix? X can be like 1 1 1 1 1, x1 x2 x3 x4 x5. This can occur also, right, for a multi-dimensional case. Now you have a multi-dimensional and multi-data. There it was only one data. Now you have multiple data, then you will have 1, and so on. So this will be a matrix, right? So this matrix, let us suppose you have n features. So this matrix will be having a dimension of x will be the number of rows, that is basically the actual features, actual feature space that you have, that is n cross m plus 1, right? Because I have one more thing, that is this ones. Now I am now let me tell you why I am defining this ones. These ones are there to get the bias term. The bias means if the linear regression has an intercept, let is y equals to 2x plus 1. In that case we need that 1, that is the bias. We call it bias. So this bias will be coming from that theta 0. This is the bias, and for this bias we need these ones. So one dimension will be higher here, m plus 1, whatever be the number of samples plus 1. So now what we will do is, am I going correct? Yeah, I may be going. Yeah, that's fine. And theta will be your, okay, now tell me what will be the dimension of theta? What will be the dimension of theta? So here I have defined it to be a theta x. I have defined it to be theta x. Now if you have to define it to be x theta, for that case you have to write like 1x and theta 0 theta 1. These are all conventions. You can write either of them. Fine. So if you go, I am not going down into calculating all of these things. So I am rubbing this. You can calculate on your own like what it will come. So let me define x to be a, let me, for sake of simplicity, let me take it to be x theta. Rather than theta x, let me take x theta. Just transpose each of them and take it to be their original vectors. So now what will happen is that if you do this, it will be x theta minus y whole square. Now y is a vector also. So after that this now what great thing we have, now this is actually the cost function j, because already we have summed up everything. So now when we are doing this summation is not at all required, because for all the samples I have done all the summation and all. So just by doing 1 by m over here, you are done with it, because you have got the average right away. So now the thing is, did anybody question me? Is this possible? Nobody questioned me when I put this square. Nobody questioned me how I am putting this square in vector. How are you going to square it? How are you going to square a vector? Means what? Cross. Dot product. Dot product is other, not cross. So what we will do is not only dot. For squaring it is dot product with its transpose, not just dot product. For squaring it basically means cross dot product with the transpose of the vector. So here it will be like x theta minus y transpose into x theta minus y. This thing is the actual cost function. By 1 by m, I am neglecting the 1 by m. Just put it by yourself 1 by n. That's not a big deal. So this is wrong. This is not the case. This is the actual case, and 1 by n later. So this is the actual case. Okay. Now I am telling you to differentiate a matrix. So how can we differentiate a matrix? Now the thing is here, all these x and y's are constant because we are already given the values. So the variable that we have to minimize is what? What? What are we going to minimize? With respect to what are we going to minimize j? With respect to theta. So you are going to differentiate with respect to some theta I each time, right? So in the case like when you find this thing is, I am not going to find all those derivatives, theta I, theta 1, theta 2, theta 3. You have to find all those derivatives, and after that what you are going to get is actually this thing. So when you do the derivative and all, and after that when you do this thing, I am directly writing the result. You can go differentiate, but directly writing the result, that will be theta will be equal to x t x transpose x over inverse multiplied by x transpose. So now this thing, theta is equal to x transpose x whole inverse x transpose y. So this thing is the final answer. So just by doing this, without doing anything, you can get the theta out, right, directly. So now where is the problem with this? Can you tell me where is the problem? Where is the problem in this method? There is some problem. What is the problem in this method? What? Inverse. Okay, 1 point here. Same inverse. Okay. So now one thing, x transpose x, this thing, is it invertible or not? This is a good question. X transpose x is invertible or not? But in computer, in MATLAB or Octave, whatever is there is another function known as pseudo inverse. That pseudo inverse can invert a matrix which is non-invertible. Even if it is determinant is 0, it can find a inverse. So that is a problem. I get the point. That is a problem. But there is some way around that problem. So can you guess another problem that it has in this related to inverse, not inverse condition of inverse. Rather than that, there is a problem with inversing. What is the problem? With inverse, there is another problem. Even if we have way around with the determinant thing, what can be the other problem? Any guess?
The determinant of that is 0.
That we can get around that. We have some other function known as pseudo inverse. That pseudo inverse can calculate a inverse of a matrix whose determinant is not 0. It can get you a matrix. Get you. That is a valid point, but we have a workaround with that. But can you guess another problem with inverse? There is another problem with inverse. Does everyone knows time complexity theory? Most of you would have had a CP session where they would have talked about time complexity, right? So, what is the time complexity of this inverting a matrix in C++, means coding, means in computer? What is the time complexity? If the matrix has an order of n means a square matrix has an order of n. What will be the time complexity in big O notation? Anyone knows? For inverse, what is the time complexity? The time complexity is O of n cube. For inversing, the time complexity is O of n cube. Now, if you have 10,000 data, think of how much time you will need to find the actual solution. So now there is a problem with this inverse. It gets so huge that the computer can't even calculate in that real time. So we have a problem. If we cannot get a simple linear regression problem out with our hands, then how are we going to solve real world problem? Right? So this method is known as the normal equation. This is the normal equation. This equation is known as normal equation. We can use normal equation when the data set is small, then we can use, because x, t, x, this dimension depends on the data sets, how many points we are having. So this formula cannot be used everywhere. So now we are going to another method that is known as gradient descent. So does anyone have any idea of gradient descent? Anyone? No idea? A little bit. Okay, so the thing is, how much time? Oh, okay, I have 10 minutes. Okay, so gradient descent. And by the way, in supervised learning, this theta 0, if it is a means having only theta 0 and theta 1, there theta 0 and theta 1 has some special characteristics. I can just going to write down this. Theta 1 that will have is covariance of, do not, if you want you can go into details why I am writing this. This will happen. The thing is I am telling you this will happen when you get all those values and calculate this will come out to be the result, because when you get ds dj over d theta 1 0, if you do this, you will get this thing, and theta 0 will be mu y minus theta 1 minus theta 1. So if you have got this theta 1, after getting theta 1 you can put the theta 1 here and get this, because you have mu x, you have mu y, you can get the value of theta 0, right? But that is the thing. This is just special info. So in the terms of gradient, so I am not going into the coding part of gradient descent. You can go and code your own gradient descent in C++. I will be recommending in doing it in C++ rather than in Python. Why I am recommending C++, even if it is ML, I am recommending C++ to get a in-depth knowledge of how data structure works. Okay, so data structure is always needed in ML. So you should have a grasp of how data structure works. For that you should do this assignment, like gradient descent algorithm, implement in your own in C++. So let me tell you, like, what have I done? What have I drawn? Can anybody tell you? What thing will look like this? What? Which of the function, whatever I have defined, which function is this? No, parabolic I know, means which function will look parabolic? Cost function. The cost function will look parabolic. We have to minimize the cost function, right? So we will be plotting cost function against the x values. So this is the cost function. So this is basically j and this is x. Okay. So we have to minimize x theta. That is the thing. This is the cost function with respect to theta. If I plot, it will look like this. It is a polynomial of 2-degree parabola will be there. Now if you increase the order, or there is some non-linearity in the data, then that may not be parabolic. That data can be like this. It means that the plot can be like this or so. Fine. So I will be coming to this graph also. What will happen in that graph. So now when we have like you have a data of y equals to 2x. So let us suppose we started with 0, maybe theta 0 is equal to 2, theta 1 equal to 0. The prediction will look like this. Right. So now can you tell me where in the point it should be like? Well, there will be some point, right, where the value of j is there and theta is there. So actually let us suppose, I am supposing that it is here. Means with respect to some theta, maybe it is theta 0, means both of the graph will be there, theta 0, theta. So with respect to theta 0, may it be 2, yeah, it may be 2, and let me actually remove this one, put it here. I am putting it here because as you can see with respect to theta 0 will be only minimized when theta 0 is 0. So minimum in this graph should be at 0, right? That is why I just shifted the origin. So let us suppose it is 2, so there is some error. Obviously there are some error over there. Fine. So now gradient descent algorithm in a graphical way, what I can say is, what will happen is gradient at this point. Can you guess the gradient at this point will be this one, right? Gradient at that point on the function will be this one. Descent, gradient, descent. So if we move opposite to the gradient means the gradient is pointing like this. This is the normal over there. Okay, and this is the gradient over here. The curve goes to Z. That is why it is over there. So if we move opposite to the gradient, can you see what will happen to this point? Means if the point is movable, the point moving opposite to the gradient will obviously go near the value nearer to optimal value, right? Because we are descending to this point, because we have to reach this point, but our computer doesn't know how to differentiate. So what are we doing is, we are taking this point and moving it more towards the optimal value. This is gradient descent. So now how much we will have to move? That is a great question. So can you guess a number that how much we can move to reach here? No, that is actually not how step is defined. It is known as step size. Step size is how much step you are taking. So that is defined by you. There is a hyperparameter that is known as hyperparameter that you are defining. Fine. So if you are defining the hyperparameter, let us suppose your hyperparameter is too high. Let us suppose 4. Let us suppose it is 4. So what will happen is, from here it will go to here. If your hyperparameter is too high, it will bounce to here. Now, if your hyperparameter is 100, so what problem will happen is, it will not move here, it will move here. And after again you are 100, it will move here. So what problem you are facing, you get it. Every algorithm have an advantage and has a disadvantage. This is the disadvantage. If you have a very high learning rate or step size, this is also known as learning rate. So step size, then you are going to shoot off the curve and you will be never reaching the minima ever in your lifetime. So you have to take a optimal value, and these are, in general case, we take it like 0.003 or 0.001 to 0.1. These are the values, and in between we can choose anything we want, and it depends on your model. By the way, you have to just put the value, check it if it is converging or not. If it is diverging, you again change the value. Like that you have to do. So if you take a correct amount of step size, so it will like go there again, there, and maybe there. So it can reach the optimal value in finite time, and this will require only how much steps? 1, 2, 3, 4, 5, 6, 7, 10 steps. Suppose it is 10 steps. So if the matrix has an order of 100, we are reaching in only 10 steps. That is not even near to n cube. It is not even root n. It is like root n, or maybe so. It can reach in very less time, it can reach in moderate amount of time. That will depend how we are setting those step size and the function is there. So now the thing is, can you tell me what problem can occur here while moving? What problem can occur? No, local minima you may not reach. One point is overshooting. What is the other point that can happen where you do not reach the optimal value? Think of it. What? Yeah, you can actually oscillate between the points. So what will happen is, if you have a step size such a value that it can oscillate near the optimal value in between 2 points. If it gets symmetric, it goes on bouncing back and forth, then you will not be reaching the optimal value. Optimal value you won't be reaching, but near optimal value you can reach. So our point is to reach near optimal value. Not always the optimal value is reached in finite time. So after that, there is always a threshold. Now what is the threshold? Like the error that we were calculating, like j, we are calculating j, right? So if j is less than 0.01, we are setting a threshold. If j is less than 0.01, even if the theta, let us suppose for theta equal to maybe 0.001, it is getting less than 0.101 eventually. So we will stop the algorithm. In code, if this happens, break out of the loop and stop the algorithm. Why we are doing that? So we do not want to get into this infinite loop, right? And setting this thing is also a hyperparameter. These are the faults with our gradient descent. Gradient descent is not the all-round solution of everything. It is the algorithm, and these are its fault. So now you will be getting something this plus theta 1 is near about 1.99 maybe. So you can approximate it to this one, but you may not directly get 2 0. But in normal equation you will be directly getting 2 and 0. Normal equation will give you the exact point 2 0, but gradient descent may give you a little bit of error, 1.99 and 0.0. We can compromise with that because the computational resources are costly. So to save the computational resource, we do that. So this is actually the gradient descent, and this is actually used to calculate the minimum of that. So I won't be discussing the logistic regression because logistic regression is nothing, just a brief intro. We will be discussing logistic regression in another session. Just put a sigmoid in h theta, and this will be the y cap, our predicted value. If we do give this sigmoid value, we will get the logistic regression. We will discuss in detail why we are putting this and all in a logistic regression session. But the thing is that all the algorithm will remain the same as it is. The predicting function, this hypothesis will just change, nothing else. The hypothesis changes, that's all. So logistic regression we will discuss next session. And for your homework, I can give you 7 questions. If you are interested enough, I will give you 7 questions. I will send you, like the questions are like how to select alpha, what are feature scaling in gradient descent, means why we will be doing feature scaling, you have to write it. You may not write, you can just read. Is fixed value of, okay, now there is a question. When I was taking this alpha, the step size, okay, now in gradient descent, let me write what the formula is. So theta 0 is equal to, this means replaced by. After calculating the next step, it is replaced by 0. It is basically like a is equal to 1, a is equal to a plus 1. You do this in C++, right? You can just write it a is dot equal to a plus 1. This is the same thing in maths. You just replace that with a dot equal to function, so that it seems like take the old value, do the right hand computation, then put it to the left hand. Theta 0 is equal to theta 0 minus then yeah. So now this is the step size that I was telling you. The step size is this alpha. This is known as learning rate, this step size. So now can you tell me, like, do you have any question regarding alpha? Means there should be a question regarding alpha. Can you just guess it? A question regarding alpha. I'll be sending you the questions anyways. So can you just give me a question regarding alpha? Just give me. Frame a question regarding alpha. This is the question. Frame a question regarding alpha is a question. There is a nice question regarding alpha that everyone should have while starting out this. Think for a bit. Anyways, I will be telling, like, here the gradient descent may converge to this minima, may converge to this minima, or may converge to this minima. This is also a big problem for gradient descent. There can have multiple minimas when there is. This is a linear regression case. When there is no linear regression, there are data is following something like e to the power x plus sigma x plus something of tan h inverse tan hyperbolic of x. All these functions, if I put there, non-linearity will come. Then the graph will be like this. Means graph will not be a parabolic, simple parabola, and have multiple minimas, local minimas. So it can converge to any of the local minima depending on your step size. Okay. So step size is very important. That is, the learning rate is important. Because we need this global optima. You may not reach the global optima, but you may reach also. There is a thing, that is also point. But just think of what the question. This is not the question with regarding to alpha. Think of a question. How are you going to means frame a question on alpha? And now the coding session Harshit will take.